Descriptive statistics. Well, descriptive statistics allow us to understand the quantitative summary of any variable in our data. So based on the observation that we have, we can try to understand what kind of variable it is, and we can just understand what are the underlying characteristic of that variable. It permits us to analyze the or describe many pieces of data with just few indices. Uh, Descriptive analytics has two kind of measures. One are central tendencies, which can be divided into mean and median, and another one is dispersion, which is range, variance, and standard deviation are its measures. What central tendencies are? Central tendencies are the middle values of the data frame or any variable. Or dispersion just shows us the range or the stretch of that particular variable. We will just discuss each and every of these measures one by one. First, we will understand central tendencies. What central tendencies are? Central tendencies are just gives us idea about the middle point of that particular variable. First, we will move to the central tendency measure, which is mean. So, what is the mean? Mean is a simple arithmetic mean, the sum of the total values and divided by the number of values that we have. We have been seeing this mean or arithmetic mean. We have been understanding this from quite a long time. What mean does is it just gives us a quick idea on average of a variable or where the middle point might be. Next, we will move to median. What happens is mean is not always a good measure of finding a central point, because what if our variable or values in our variable are not distributed similarly or not distributed equally? If there is any outlier or some values which are very far away from the rest of the values, the mean would distort so much, or mean would not give us a exact value of true center of the value would not be, or true center of that variable will not be shown by the mean. So that's why the median comes in. So if there are any outlier or some kind of value which are very far away from the center, it will just give us the idea where the actually central point lies. So if we just consider mean versus median, and if there is a lot of difference in mean and median, we would be able to say that there are some outliers in the data frame. What is the median? Median is when we put all the values of a variable in a ascending or descending order, the middle value or the 50% of the value, or where the middle point lies, that would be our median. We will just try to understand how median can allow us to find outliers. Let's just consider this data vector. Here are a few values, and we can see that most of the values are like 1.9, 8, 1.9, something like that, and there we can see that there is one value 9. So 90% of the values are above, 90% of the values are less than 2, and 2 is the mean of this whole vector. So if we just try to understand that 90%, if the 90% of the value are less than the mean, there might be some other value which is very far away and which is trying to compensate the value to get the mean as 2. So in this kind of scenario, we would be considering the median, which would be a very good help to find if there is any outlier. So how do we calculate mean? Mean can be calculated when we have a vector. We can put it into ascending order, and we can count and get to the part where the middle value lies. So here the middle value is 1.4. So next, what we can do to find if there is any outlier or not, what we can do is we can compare mean to median. If the mean and median are not very near or are not the same value, we can understand that there is some sort of dispersion or some sort of underlying cause where one value might be far away from the central tendency or central point. It just helps us define that. Mean and median in Python. Now next we will try to see how we can calculate mean and median in the Python, and we will understand what it gives us. I will just import the data set, but first we will need to use pandas at pg. Okay, so I will import pandas data frame as pd, and then I will import a data frame, income data frame, and we can see that there are 15 columns and 32,000 observation around. So if we have to find the mean of any variable, what we can do is we can go to the whole data set and we can use square bracket to redirect to that column name, and then we can use the function dot mean to find the mean and dot median to find the median of that variable or that column. So I will just run this code, and to find it, the mean of this variable capital gain will be stored in gain underscore mean variable. And if I run this gain mean, we can see that the mean is 1077, and if we try to calculate the median, and if we see what the median is, we can see that the median is 0. So we can see that mean is 1077 and the median is 0. It means that 50% of the values are below 0. Okay, but the mean is 1077 and the difference in mean and median is very high. That means that there are some values which are trying to compensate the whole division of the values, and it's giving us a mean of 1077, which in the end implies that there might be some outliers in this capital gain variable. There is a lab for you. You can import the online detailed data set, and for the unit price you need to calculate mean and median, and we suspect any outlier depending on if there is a lot of difference in mean and median values. Next is dispersion. Well, central tendencies are not enough to understand a variable. Central tendencies just tell us the middle value, not the degree of range or the stretch of the variable that we have. So measure of dispersion is quite necessary to understand what the values are, what the range of the value is, or where one outlier could be lying, or where we can draw a point or draw a line and say that okay, after this point we will be considering the rest of the values as outliers. So dispersion, what could be dispersion? So just like I discussed, central tendency is not enough, so getting just a mean or median will not just help us. For example, we have 2 companies and the profit by the month of these companies. If we see in company A, it is giving sometimes a lot of profit percentage, and sometimes it's very low, and sometimes it's going for some loss also. But the mean of the over the stretch of 1 year is 15, and the over of stretch of a company B, which is giving us constantly some profit, so mean of that profit from the company B is 15. But there is one case, company B is always giving us some positive output or profit. So if you are trying to buy a share of company A or company B, you will definitely try to prefer company B, because any time of the year or any time if you invest your money, company B will give you good results. But this is a simple thing, but what it signifies for us in a statistical way, the measure of dispersion becomes very vital in such case. Like the dispersion, meaning that the range where it's stretching from -8 to the maximum 43, that's very important. But in here, if you try to see the dispersion from 12 to maximum value could be 18, the range of fluctuation is just 3. We will just see how the dispersion can be calculated, or what are the other measures to calculate the dispersion. So variance and standard deviation are very widely used measure for finding the dispersion. So dispersion is actually the quantification of deviation, okay, from each point from the mean value. So variance gives us a degree of stretch, or how far the number is spread from its mean. So how do we calculate variance? What we do is we find the mean value of a vector, and then each value we subtract it with the mean, and then we do the square of those values, and we sum all the values. So for company A, here we are seeing that the variance is 352, and for the company B the variance is 4.9, meaning the company A is giving us very high fluctuation in its profit, and company B is giving us just very low fluctuation. So basically we can, in other word, we can say that the less the variance, the less noise in our data. Here is the formula to calculate the variance, just like we have discussed over here. Next measure of dispersion is standard deviation. So what standard deviation does? Standard deviation quantifies the variation in same unit of the variable. So variance is a square of standard deviation, meaning if the value was in meter, the variance would be in square meters. If the if the value is in meters, the standard deviation would be in the same unit, which is also meter. So what standard deviation signifies is, if the standard deviation is low, the data points are very near to mean. If the standard deviation is very high, mean the data points are spread all over the high range, or it just signifies or allow us to understand that yes, there might be some outliers, or the data is very dispersed. Next we will see how to calculate the standard deviation and variance in Python. In Python we can use .var function to find the variation and .std function to find the standard deviation. So what we will do is we have already imported the income data set. What we will do is we will create two subsets. One subset would be just for the United States residents, and another subset would be not the people who are not United States resident, or the data would not be for United States, meaning the rest of the world data. So I am just dividing this data frame into US income data set, and the next I am dividing it into other income, meaning the rest of the world's income. So if we see that out of 32,561 observation, 29,170 observation are for United States, and only 33,091 observation are for rest of the world. Now we will try to calculate the variance for the United States income, and if we see the value of variance, which is 5.73, and if we see the standard deviation for the United States resident, it is 2.39. If we try to calculate the variance of other, which is 13.57, and if we try to find the standard deviation of other, which is around 3.68. Now variance and standard deviation could be signifying nearly same thing, but we will just try to see, just to consider a variance at this point for USA and other. So variation of the income in education number is 5.73, and for variation for other is 13.56. What it signifies is that the education of all the population, or the people in that particular country or other countries, is very wide, meaning some people are just are educating just from high school, or they are just dropping out of standard 5, and there are some people who are getting very high PhD degrees or something. So the variance is very high. But if you just go in the United States, the variance is very low, which is just 5.7. It signifies that most of the people are getting the similar kind of degree, or at the similar level they are just leaving their education. So this also is true in, if we try to understand in the practical sense, that in United States most of the people just graduate from high school, so the variance of their education level would be low, because most of the population is just getting a high school degree. But if we go into third world countries like India and every countries, there are many people who are not even able to get a phase of school in their life, and there are people who are getting very high degrees for getting PhD. So this is how we have calculated the variance and standard deviation in Python. Next would be the left for you. You have to calculate the variance and standard deviation of these three quantities in the online retail data set.